Welcome to this lesson in quantitative reasoning. This is part 2 of 2 videos on evaluation of logical statements using negation, conjunction, and disjunction, not, and or. In part 1, we looked at or and when we had two statements involved in our compound statement. And we're going to expand that into situations where we have 3 statements that we're making compound statements out of. What you're going to see, though, is that we're only ever looking at 2 statements at a time. So all of those things we did in that first video are basically the same. You just carry over, and these become multiple step problems that you have to break down into pieces. That's a skill you need in many math classes, the ability to work from the inside out, order of operations, all of those kinds of things. We saw some of that when we did set with a unit on sets also. So we're going to learn to construct a truth table for a disjunction with 3 or more statements. We're really going to limit our work here to no more than 3. 3 statements will require 8 rows in our truth tables, which we'll show you in a minute. And if you went to 4 statements, you'd have to have 16 rows. Every time you add 1 to the number of statements you're dealing with, you double the number of rows your truth table requires, or the number of possible combinations of inputs there could be. So we're going to work with 3 statements here. So we use truth tables for this. We also use truth tables for 2 statements. So we have a variety of values here, A or B or C. We want to determine the possible truth values for all possible input combinations, like when A is true and B is false and C is true. So we're going to end up needing 8 rows. And I'll show you the reason for that in a moment. I'm going to make a new slide here. And maybe it won't. Yeah, there we go. New slide. Oh, I want just a nice blank slide. So why do we have 8 rows when we have 3 statements? Well, let's say our statements are P, Q, and R, okay? Those are the 3 different statements we have. So the 2 possibilities for P are P is true or P is false. Then for each of those possibilities, Q can be true or Q can be false. So if P is false, Q could still be true. They're independent. Now, if I have P is true, Q is true, R could still be either true or false. P is true, Q is false, R could still be either true or false. And we're going to see how many paths we get, which will give us that each path will show us a different combination of inputs. So false P, true Q, I can have a true R or a false R still. That's an F up here. And here, true or false. And if I count these, I get 1, 2, 3, 4, 5, 6, 7, 8. There are 8 paths. So what I mean by path is true, then true, then true. That's one path. And then pick a different color for this. True, then false, then true is another path. Oh, and even more, I don't have too many different colors to choose from here. I'll use the highlighter. I could do true, true, and then false, and that's yet another path. Each of these ends represents the end of a different path, and there are 8 different paths, and we have to have a row for each of these paths in our truth table. So the first input row of our truth table will be true, true, true. And the next row will be true, true, false. And the next row will be true, false, true, true, false, false. So I'll have 4 where P is true, and I'll have 4 where P is false. And then I'll have 2 trues, 2 falses, 2 trues, 2 falses. I'm scribbling a little here. And then I alternate. So that's how we're going to set up our rows. Here would be our first row, true, true, true. And I'm going to erase all this in a moment. And actually, I'm just going to erase the 8 paths over there, and then I'll do this besides. So what that leads us to is this. When I'm creating the input columns for a 3-statement truth table, I have 3 input columns, 1 for each statement. And I will go in alphabetical order, left to right at the top to label the columns. So there's my 3 columns. I'm going to end up with 8 rows. In the first variable, half of the possibilities are true and half are false. And that's actually true for all the variables, but we literally write 4 trues, 4 falses for P. Now, half of the possibilities are true for Q and half are false for Q, but if we write them there, we never get any. If we just write 4 T's here, we just get true, true. We never get any possibilities where P is true and Q is false. So I do 2 of each true, and then 2 false, and then 2 true, and then 2 false, and that's how I end up with 4 of each there. This guarantees that if P is true, there is a way I can get Q to be false. Then in the last column, we alternate. We still get 4 of each, but the order we put them in matters. Otherwise, we don't end up representing all of the possible combinations of inputs. So if you look at these rows here, there are these paths here. True, 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 false. True, false, true, true, false, false. There's the first 4 right there from that P is true. Every single time, this is how you'll set up a 3-statement input columns. If you reverse the falses and trues, you're not going to earn the grade for that one. They have to be in this order. Okay, we have to have a uniform way of doing this, otherwise we can't compare our work to each other or one statement to another. All right, so it becomes more complicated when we have 3 statements because there are now 8 possibilities to consider instead of 4. So we're going to make, we don't necessarily need a whole truth table to evaluate a single statement. Let P, Q, and R be the following statements. James won the game, James lost the game, James tied the game. What is the value of the disjunction P or Q or R? Well, so when there's no parentheses in logic, you say, well, what do I do first? You work from left to right. So really what you're doing is you're taking 2 at a time. P or Q. Now, if either one of these is true, this stuff in the parentheses is true. So either James won the game or James lost the game. Or James tied the game. Those are the only 3 possibilities that could happen when you play a game. So even if he tied the game and this comes out to a false, then the R is true and you end up with a false or true. But if he won or lost the game, if he won the game or if he lost the game, this is true, and no matter what R is, it's true. So you need 1 statement to be true to make this 3-statement disjunction because they're all or. These are all or. So, and those are the only 3 possibilities that can happen when you play a game. So the value of this statement would have to be true. So we can use conjunctions and disjunctions in the same statement. Okay, compound statements can be written using both. And in order to determine the truth value, we have to consider the truth value of one compound statement with a single operator at a time. In other words, you're just looking at 2 things that surround a connective, 2 statements that surround a connective. So this is the truth table. This is P or Q and R. And you're going to do the P or Q first because it's in parentheses. Just like in algebra class, you do inside the parentheses first. Here we do inside the parentheses first. Otherwise, we would move left to right and we would do that first anyway. So notice I have 3 statements, P, Q, R. I set up my 8-row truth table, 1, 2, 3, 4, 5, 6, 7, 8, and notice how the inputs are set up. 4 trues, 4 falses, 2 trues, 2 falses, 2 trues, 2 falses, and then you alternate. So no matter what you were trying to show, these 3 columns, if you have 3 statements, will be the same. Even if your statements were A, B, C, you'd write them in alphabetical order, A, B, C, and what's below would be exactly the same. It has nothing to do with what you're trying to find the answer to, the compound statement you have, other than the fact that it involved 3 statements. Every single time there are 3 statements, these first 3 columns will look exactly like this. Now, notice I make a new column for first I start by evaluating P or Q. So when I'm evaluating P or Q, this is harder to do on paper, I'm going to do it for you. I can ignore R. I don't care what R is. It doesn't matter. It's not involved. So I'm looking in row 1 to find out what value goes here I look here and here in row 1. P is true, Q is true. Now remember, for OR, as long as one of them is true, I get a true. So I know in the first 4 rows, P is true. So I know in the first 4 rows, I'm going to be true with the OR because I have at least one true. Once I have a true, I don't care if the other one's true or false. My OR statement will be, my compound statement made with an OR will be true. Now I look in the 5th row. I have a false or a true. Oh, there's my true, so that makes this true. 6th row. Oh, false or true again. That makes this true. And I look at P and R in this P and Q, sorry, in the 7th and 8th rows, and they were all false. So there's no true in the 7th row, so P or Q is false. There's no true in the 8th row, so P or Q is false. So it looks really complicated because I have all these 3 columns. I really only have to consider what's in. It says take whatever's in P in this row, whatever's in Q in this row, and join them with an OR and tell me what you get. So after I've done that, I'm going to erase my marks here. I'll leave those. I take this. So that's this right here. So I want what in this row, I want what's in this column, and this one is an and. So I need true and true is the only true. The rest are false. So what I'm looking at is what's in this column here, because that's P and Q, and this column here, because that's R. So to get the answer in the first row here, I say I have a true, and the order doesn't matter in the end, so it doesn't matter that I said the R first. Order only matters in the if then. True and true. Both are true, therefore I write true here. Here in row 2, R is false, so my and is false. If I have one false, I can immediately write a false. In the 3rd row, so this column here is my answer column. In the 3rd row, I see I have a true for both of the things I'm joining together with this and. So notice I figured this P or Q out first. I don't do this all at once. I do it in steps, and I make a column for each of the steps. So P or Q, sorry, where is it? 4th row. R is false. I don't even need to look at P or Q. False. 5th row, I have 2 trues, so I get a true. 6th row, R is false, so I get a false. 7th row, R is true, but P or Q is false, so I get a false. And for this last row, we haven't filled it in. Why don't you stop for a second? Stop the video if you want to, and fill in that last space. Okay, so hopefully you stopped the video, restarted, or you figured it out in the time I waited, and you're back. So I look at to fill in this last box here, I take P or Q is false and R is false. That's going to be a false. This column here is our final result. That is the truth table for the statement P or Q and R. So that is how I write the truth table for that. And notice though, when I only ever had to consider 2 statements alongside a connective. Here, I considered whatever the value of P was with the value of Q joined with an R. And then once I had that, this was, now I knew the value of this. So this was either true or false, and I was anding it with whatever R was in that row. So it's this value and this value, this value and this value. If you break it down into steps, that's all you're ever doing is taking 2 truth values at a time and joining them with a connective. So just because there's 3 statements, it takes longer to do, and it's a process, and you have to work carefully, which is a struggle, I know, for some of us. But it's still just those same basic truth tables. If I have both sides are true with an and, it's true. If I have an and either side is false, it's false. If I have both sides are false for an or, it is false. But if either side is true, an or statement becomes true. So what if I just had a single statement to evaluate, though? I don't want the whole truth table. I just want the truth value of this statement under these conditions here. So statement P is 10 is greater than 6, Q is 4 is greater than 8, R is 3 is less than 5. Now remember, with these symbols, you point to the smaller one. So this is a less than, And I'm pointing to the smaller one, so the one on the left must be, this is a greater than. So, you're pointing to the 6 here. So if the 6 is smaller, this is true. So statement P is true. Statement Q, 8 is not smaller than 4. Statement Q is false. And 3 is being pointed to there, and it is smaller than 5, so that is true. So those are the 3 values. So now I can do true and false for P and Q. And that will give me a false. So this whole thing here becomes false, and I'm joining that with statement R, which is true, false, or true, which is true. So let me write that out again. I do P and Q first. So that was true and false. That equals false. Now I take the value of P and Q, which is false, and I join it with R, which is true, and I get a true. So this is done out in a row here. And if you made the whole truth table for all the possibilities, you would just look at the row where we had a true, false, true for inputs, and you would choose this as the answer. It's true. The answer is true. So that's evaluating a single statement. You don't have to create the whole truth table if you just have to evaluate one set of conditions. But if you want to know what all the possible outcomes are for any possible input, you write the whole truth table. Or if you're told to write the truth table, you would write it for all. Here we only constructed one row of the truth table, really, is what we did. But you don't even have to write it in a table like that. You could just do what I did, order of operations, do the parentheses first. Then you found that this is the value of the parentheses, and it with R, or it with R, sorry, that's an or, and you get true. So, negation means opposite. So if the value you start with is true, the negation of it will be false. If the value you start with is false, the negation of it will be true. We say not P when we write this. So they will always have opposite truth values. So here is okay, so we have 2 statements here. We just have P and Q. So the first thing you need to do if you're writing a whole truth table is decide how many rows. There'll be 2 squared. So the 2 comes from the base 2 comes from the fact that each of the 2 statements has a choice of true or false. That's where that. This 2 comes from the fact that there are 2 statements. There are 4 rows. If you just want to remember that for 2 statements there are 4 rows, that's fine. 3 statements is 8 rows because 2 cubed is 2 times 2 times 2. That's 8. Each statement can be either true or false. Those choices are made 3 times. You get 8. But for our case here, we only need 4 rows. When we set up a 4-row truth table, we go in alphabetical order, left to right, for the input columns, and then 2 trues, 2 falses, true, false, true, false. All 2 statement truth tables will start with these same first 2 columns in the same order. So now, I have to do not P and Q. You don't want to do this all at once. Do the not P first. So the order of operations is we do not P first. So we make a column for not P. P is true, not P is false. P is true, not P is false in the second row. P is false in the third row, not P is true in the third row. P is false in the fourth row, not P is true in the fourth row. Now, for some reason we have a mistake here. We're actually making the truth table for not P and not Q. They only wrote not P and Q here, but we want to do not P and not Q. So rather than try to guess at these, we write out the individual. We do not P and we do a column for not Q. And then we can just join those 2 sets of answers with the and statement. So not Q. In row 1, Q is true, so not Q is false. In row 2, Q is false, so not Q is true. Row 3, Q is true, not Q is false. Row 4, Q is false, so not Q is true. So I fill those in. Now, let me see if they actually did what they said they wanted to do. Now, this is funny. They did not P and Q here. So if I were just doing not P and Q, and I can still do that, I'll do not P and Q first here. I'm going to take this, whatever, row by row, this column and this column, and look at it. So in the first row, I have a false with a true. so I get a false. In the second row, I have a false. As soon as you get a false with the and, this is an and. It means you have to have two trues to get a true. So the second row, false, because it's a false. Look, the third row, Q and not P are both true. And the fourth row, Q is false, so that becomes false. Now, if I were to make the final column for not P and not Q, I would have to look at some different rows to do not P and not Q, and I'll do this one in red. I'd have to look at the columns, or rather different columns, the columns for not P and not Q. And in each row, see in row 1, I see a false. I'm looking here because that's what I'm joining together with the end. I have a false. In the second row, I see not P is false, so that's false. Third row, not Q is false, so I immediately have a false. I don't even have to look at the other one. Now, not Q is true, so let's look at not P is also true in the fourth row. So that's what I get. So this column would represent the value of not P and Q, and this final column I've written here would be the value of not P and not Q. Okay, so it's going to take a little practice. You're going to have to do the homework and practice this. So they give us another one to do here, and this is still two, even though there's three things written, this is a P, this is a Q, and there's another P. There's not three different statements. There's only two different statements. So again, I get my 4 rows, and they're set up. The input columns are set up the same for any two-statement truth table. Now, I'm not sure why they found the value of not Q here. They don't need to find the value of not Q for this. I wouldn't have written that row if all they were doing was not P and Q or P. And let me make sure they've done this correctly here. So not P looks good. Remember, if P starts out true, true, false, false, you don't really have to go on at a time. So, oh, the pattern is I had 2 trues and 2 falses, so now I have 2 falses and 2 trues for the opposite. So not P is correct. Then we do not P and Q. We're doing what's in this parentheses first. Not P is false and Q is true. So I get a false. I see in the second row, not P is false, so I can immediately write false without even looking at Q. So third row. Here and both true, so I get a true. Fourth row, I have a false, so I write a false. So now this here in parentheses is what's in this column. So I'm taking, for this next part, let me see if I can get a different color here. There we go. There we go. Okay, so for this next part, I'm doing this column, whatever letters here, row at a time, with P over here. And that's joined with an OR. So I'm looking here and here, row by row. So in this first row, as soon as I have a true with the OR, I know I have a true. So P was true, and I know in the second row, P is going to be true too. So true, true. Third row, I have a true here, so I don't even need to look. As long as I have one true, my OR is true. Fourth row, I have a false here. So I have to check and see what the value of P is false also. So I have a false. So this, again, the idea of breaking it down. I didn't actually need this column for this truth table because there's no not Q in my problem. If you wrote it, it's not wrong, but it just confuses things. Okay, so that's the last example I have here. This is going to take some practice. Don't put off doing your homework. And I will see you in class.